Hi everyone. In this video, I'm going to be walking through Cisco Packet Tracer 9.5.2.6. This is titled Configuring IPv6 ACLs. Let's go ahead and get our packet tracer opened and reset so we're starting fresh. There we go. Keep our addressing table open on the side here. I like to do a fast forward a couple times just to give all our devices time to boot up. And we're ready to begin. So the scenario behind this is that on our network here, we have a computer somewhere on this network that is constantly refreshing their web page, which is creating a denial of service on server 3, preventing server 3 from responding to other web page requests from other networks or other devices on other networks. Until the specific client can be identified and cleaned, we have to block HTTP and HTTPS to this entire network. So the network topology is only showing us this one device, but in reality there could be, a couple dozen devices, an access point or two with wireless devices. All we know is it's something on this network. So to begin, we want to start by determining what kind of access control list we want to set up, and then where we want to apply that access control list. And since we only want to block HTTP and HTTPS from this network, we're going to be setting up an IPv6 access list and want to apply it closest to the source that's causing the problem, which would be here on R1, the G01 interface. So let's go ahead and get started in the command line interface of R1. And we'll get up to the global configuration mode. I'm going to start by creating the IPv6 access list called block HTTP. We want to deny TCP from any host coming in this interface. We want to prevent them from reaching the host 2001 DB8.130.30, which is the server. We have that IP address here, IPv6. We specifically want to block that from reaching port 80. If you use port 80 in this packet tracer, it will not accept that for grading, so your completion won't go up. You have to use www for the grading purposes, but 80 and www should accomplish the same thing. It just won't for the grading for this particular packet tracer. In addition to that, we want to block HTTPS through port 443, but we still want to allow all other IPv6 traffic. So we don't want to shut everything down, just traffic through ports 80 and 443 to the server. Once you've done that, completion should sit around 40%. Applying it to the correct interface and in the correct direction will give us another 10%. So we did take a look, and we saw that it was G01 is the interface most closely connected to that network. And so we want to apply the IPv6 traffic filter that we titled block HTTP, and we want to block traffic coming in on that interface on the router. So if it sends a request for anything to the server on port 80 or port 443, this router will automatically deny it right here. And that did bring us up to 50%, so we're good there. We want to verify that the ACL is working correctly. So we'll start in PC1 and go to its desktop web browser to make sure that it can still reach the server for web access. And we'll start with HTTP, and we can still load the page there. So we'll check PC2 next, and for this, it might take a couple of seconds, but this should time out. It should not be able to access the server through that port. And so that's good. The next thing is to check PC1 again for HTTPS, and we can still load it, but PC2 should again time out. And that shows that both HTTP and HTTPS are blocked on this network for this server specifically. Alright, and even though the HTTP and HTTPS are blocked, we can still do a successful ping. So we still have connectivity, it's just HTTP and HTTPS that are being blocked. So that's good. Part 2 for this is that our logs now indicate that the server is receiving a lot of ping requests from a bunch of different IPv6 addresses in a distributed denial of service attack, a DDoS. So we need to filter ICMP ping requests to the server. If we set that up on R1, we would have to apply it to both of these interfaces. And if we try to apply that anywhere between the routers, it may interrupt our routing protocols. If we have any kind of dynamic routing, blocking ICMP can cause issues there. So the most efficient way to apply this is to block it here closest to the destination. So we're going to say on router 3, any traffic coming out this interface, and I can't even tell what interface that is, so the first thing I'm going to do is figure out what that interface is. Alright, so it's G00. So we're saying anything coming out G00 is going to be blocked if it's an ICMP request. Regardless of who it's coming from or where it's going, we're going to block all ICMP coming out G00 on router 3. So to begin, we'll jump into our command line interface and come up to our global configuration mode. Alright, then we want to create the access list. We're going to title it block ICMP. We want to deny ICMP from any source to any destination, but we still want to permit all other IPv6 traffic from any source to any destination. Once we have that set up, we should be sitting at about 90% completion. The last 10% will be applying this correctly to the correct interface, which we determined was G00. I want to give it the IPv6 traffic filter that we titled block ICMP, and we want to block it coming out of that interface. Had a little typo there, didn't get a capital L. So I'm going to come up and remove that, and then we'll try it again with a capital L. There we go. Now our completion rate should show 100%, and we can verify that because we should no longer be able to ping this server at all. Doesn't matter what device we use, we shouldn't be able to ping from these networks over to our server. But PC1 should still be able to access web pages on that server. So it looks like everything's set up correctly there. If we wanted, we could jump over into the simulation mode, which lets us watch traffic step by step. So this is a basic ping. We see that it's routed correctly all the way to router 3, and then once router 3 receives it, it compares it to that ACL that we created and says, you are part of what I'm supposed to be blocking, so I'm going to deny you access right there. And PC1 gets that denial. I think that about covers everything for this video. If you have any questions or comments, please feel free to leave them below, and I hope to see you all in my next video.